Okay, so a couple of things here, guys, before we get started. Reminder again of the overdue assignment deadline. Okay, I still want those assignments. If you're missing anything, okay, I'd like you to hand it in before 3:20 on January 19th, and then I can get it marked and get it counting for you, right? Because obviously with the reduced percentage for your final exam, it can't do as much for you. Okay, it can't hurt you as bad either, but it can't do as much for you when it's only 10%. Okay, so you want to have as many marks as possible going into that exam. Okay, so make sure I have anything overdue that you'd still like to have marked in by then. Okay, and also that if you are looking to get some help for your final exam during exam week, so you've been doing some review and you forget how to do mole equation calculations or something like that, okay, you can pop in and see me, okay, January 21st from 1 to 3, okay, or January 22nd from 9 to 11. Okay, those are the only times my room is not being used for an exam. Okay, so you can pop in during those times and get some extra help, or look at your old tests or whatever it is you want to do when you come in. Obviously, you don't have to come in; it's not required. Okay, but I am available to help you during those times if you want it. All right, so let's look at Unit 4 here. The thing about Unit 4 is this: it's very short. So there's not a whole lot of material in it. But the unit exam counts for the same amount as all the other unit exams. So it's a real opportunity, okay, for you to raise your mark because there's not as much stuff to know in this unit. So you can become a master of that material because there's less of it to master. Okay. Now that said, there are several concepts that overlap. Okay? That is that they are part of many things in this unit. Those overlapping concepts would be things like heat transfer, conduction, convection, radiation. Okay? Those are part of a lot of things. Factors affecting climate is part of a lot of things, okay, that we talked about in this unit. Okay? How energy gets distributed was something we talked about in like 4 lessons out of the 7. Okay? So make sure that those are things you go over, okay, fairly in depth. The exam is going to ask you to apply quite a bit of what you know. Okay? There'll be some questions that will be kind of recall, but most of the questions are going to involve you applying what you know, especially about heat transfer. Okay? We'll talk a little bit about that as we go along. Okay, first concept we went over in this unit was the components of climate. Okay, first up, we talk about what climate is, the prevailing weather conditions at a location, and that is made up of temperature, precipitation, light, and wind. Now, the way that this is going to be tested, okay, it's actually, the components of climate are actually in several questions, but the main way that this is going to be tested is, there's a question in the written response that is a map of Canada with one city identified on it, so an arrow pointing at that city, and the city is mentioned in the question. Right? What you will have to do is, based on that city's location, you will have to tell me what the components of climate would be like in that city based on what factors would most affect its climate. Exactly what you were asked to do in your Climatograms activity. Okay, and don't worry, I'm going to pick an obvious city, okay, so that this will be fairly straightforward. Spoiler alert, it's not going to be Okotoks because I'm about to tell you how this question would sound if it was Okotoks. Okay? So if this question had the arrow pointing at Okotoks and said, describe the climate of Okotoks based on the factors that would affect it. Okay, this is what that would sound like. The factors that most affect Okotoks' climate would be latitude. Okotoks is very far from the equator, and as a result, the amount of light that it receives will be highly variable between winter and summer, not only in duration, but also in intensity. Okay, obviously we get more hours of sunlight in the summer, but it's also more intense because it's more directly overhead. Okay, this could affect the temperature of Okotoks. Okay? Not only is it far north, so it'll be generally colder, but it will have very distinct seasons. All right, I've just talked about one factor affecting climate and how it mostly affects light. Okay? I talked a little bit about temperature. Okay? So I've covered kind of two of the components with one factor. Okay, second factor affecting Okotoks climate, altitude. Okotoks is 1,100 meters above sea level. I would not expect you to know the altitude of the city I'm picking. I'm going to pick a city where the altitude will be obvious based on its location. Okay, so the altitude of Okotoks is 1,100 meters. That is fairly high altitude. And altitude causes decreases in temperature. So Okotoks would be slightly colder than an area that would be closer to sea level. So I just talked about a second factor and that it affects temperature. Okay, third factor affecting climate in Okotoks would be proximity to mountain barriers. The Okotoks is tucked in right behind the Rocky Mountains, and this would lead to drier conditions because most moisture would not make it over the mountains. It would be in the rain shadow, okay? And it would also produce unique wind patterns, okay? Causing Chinooks or southwesterly winds most of the time. Did I just cover all four components of climate with three factors? I talked about temperature, I talked about precipitation, I talked about wind, I talked about light, okay? And all I talked about was latitude, altitude, and proximity to mountain barriers. That's what I would expect you to do. You need to look at the city I give and say, okay, what are the three factors, maybe four, that would most affect this city's climate, and tell me how and why. Okay, pretty straightforward, right? So that's application of knowledge. Yes, you also have to recall what the factors affecting climate are. Okay, I'm not telling you what they are, you have to know them, okay, but you can do that. Okay. All right. Then we talked about climatograms, okay? And we said yesterday when we were going over biomes, okay, that what you're going to have to do is match them to a biome. Okay, so I'm going to put a climatogram on there, and you're going to have to say that climatogram fits with this biome because. Right? It's a 5-mark question. So if I were to, let's say, give you a climatogram that had a flat temperature line around 27 degrees Celsius and precipitation bars that were pretty much level all the way across, and they were, let's say, 250 millimeters per month, okay, what would it fit with? Okay, so it would fit with tropical rainforest. All right, so how many marks would you get if you said tropical rainforest, it's hot and wet? Out of 5. 2. Yeah, you got the right biome and you said something. Okay, you want 5 out of 5, then you've got to explain it. Okay, so you could say something like the temperature line on this climatogram is flat, indicating this biome is near the equator, okay, or a tropical biome. Okay? The precipitation bars are very high, indicating regular, heavy precipitation, which would produce lush forests like in the tropical rainforest. There would be no distinct seasons here. That's a 5 out of 5 answer. Okay? We talked about all of the stuff that was on the climatogram and why it supports it being a tropical rainforest. You didn't just say, rainforest, hot, wet. Okay? Everyone follow the difference? All right. That was something we struggled a little bit with on the biology unit exam. Okay? We put in the bones, but we didn't put any flesh on the bones, okay, for our answers. Okay? We just had the skeleton there. Okay? We need to have more than just the skeleton of the answer. Put the flesh on the bones on your answers here. Okay? Maybe that's kind of a gross example, but it's what came to mind. I don't know why. Okay, so that's what you have to do with the climatograms. All right, the day after that, okay, we talked about energy transfers in global systems, and we talked about the 3 fates of solar energy when it strikes the Earth. so the three fates of solar energy upon encountering the Earth are absorption, reflection, and conversion by photosynthesis. Okay? If the energy is absorbed, what will happen to the temperature? It'll increase. Okay? If it's reflected, there'll be no change in temperature because the energy is just bouncing off. What determines how much energy gets absorbed and how much gets reflected? Albedo. All right, is that a word you'd probably want to work into your answer? I would. Okay? Because that demonstrates to me understanding, right? If you just say, yeah, it might, some of it might heat it up, that's not really going to get you much. Okay, so yeah, talk about what happens when it's absorbed, talk about what happens when it's reflected, talk about what happens when it's used, okay, or converted by photosynthesis. Talk about albedo, okay, being the reflectivity. Higher albedo means more reflective. Right? Here's how that question's going to go. I'm going to give you a satellite photograph of an area. Okay? And I'm going to ask you to explain to me what would happen to the light striking that area. So you need to look at that picture. It's in color. Okay? Because color could be important, right, for the albedo. Okay? And also possibly for the conversion part. Okay? If the whole area is covered in snow, then there's not going to be a lot of conversion. It's going to be mostly reflection, right? Snow has a high albedo. It's white. Okay? Light-colored things reflect more light. So that's the kind of analysis that you'll have to make. You have to remember the three fates. You need to remember what affects them so that you can answer that question. Does that make sense? So you'll have to talk about, given this area, given the characteristics I see in the picture, here's what's going to happen. Lots of it's going to be absorbed, or lots of it's going to be reflected. Explain with albedo. Talk about whether you think any conversion or how much you think is going to go on based on what you see. Okay? I'm going to try and pick an area somewhat familiar to you. Okay? All right. Now, energy transfers comes up time and again on the test. You can work in this stuff into many of your answers, okay? So keep that in mind. This isn't just for that one question. It can also be for others, especially the albedo part. Okay? Now, what are the three ways energy gets transferred? Three methods of heat transfer. Conduction, convection, radiation. Okay, those three are another three things that come up over and over again. You can probably use them in half of the answers, maybe more, okay, for the written response, right? Like you could talk about convection in probably all of them, because what do we call convection within the Earth's atmosphere? Wind. Okay, wind is another big thing we talked about over and over again. So, okay, keep that stuff in mind. But, okay, you're going to have some things that are going to ask you about convection. You're going to have some things that ask about convection, okay, or conduction, about radiation, all of that kind of stuff. Now, once this stuff has happened, then the energy can get transferred on a global scale. The atmosphere plays the biggest role in that because it's the most fluid. That's where convection or wind can occur. The atmosphere is also responsible for latent heat. Okay? It's actually an interaction between the atmosphere and the hydrosphere, which is all the water, right? What's latent heat again? Okay, probably something we should go over then. Okay, latent heat is the energy stored in water vapor. Okay, what wind mechanism is responsible for moving latent heat around? Jet stream. Okay, is that something you should probably mention when you're talking about global energy transfers? Okay, these are the things you need to think about. Again, this is, yes, you have to memorize some things, but I'm not asking you to just regurgitate them. I'm asking you to apply them. Okay, how does energy get moved from the equator? Convection. Okay, explain how it works. Jet stream, moving latent heat, that's moisture-laden air masses going from one place to another, carrying this water vapor, okay, carrying that latent heat and having it go to another place. Okay, all of that is important in terms of how does energy move from the equator to more northerly areas? How does it move around the globe? It's wind, it's convection, it's latent heat, it's the jet stream. Okay, okay. There's absorption. Okay, obviously, and when it's absorbed, maybe it gets converted by plants living in the lithosphere, okay, stuff like that. All right. As I was saying, conduction, convection, and radiation are things that are going to come up in many of the questions, but there's one question that really focuses on them entirely. And that's going to be an application question about heat transfer. Okay? It will be about, not on a global scale, but on a small scale, like a device or a structure. Okay, so we're talking small scale here. Okay, a device could be something like my thermos coffee cup. Okay, and how it keeps the coffee hot for long periods of time. How does it do that? Well, it prevents heat loss. It prevents convection from occurring. It prevents conduction from occurring. It prevents radiation from transferring the energy out from the coffee to the surroundings. How does it do that? Okay, that's where you come in. You have to explain. Okay, how does this device or structure prevent energy transfer? Or it could be, how does it harness energy transfer? Okay, if I want to get lots of energy in, then I want to do the opposite. Okay, I want to have something that's dark in color because it has a low albedo and it'll absorb lots of energy. Okay, I don't want to insulate it. I want it to get through. I want convection and conduction to carry that energy into the material in the middle. Okay, if I'm insulating something, then it's the opposite. Right? So you'd have to talk about how you might do that. We talked about that with this terrible diagram. That was me drawing what the inside of your walls look like. That's the fiberglass insulation and how it traps air, so the air can't circulate. Okay? I know, I'm a terrible artist, I fully admit. Okay? But if that air is trapped between the fiberglass fibers, then it can't create a convection current, which means it cannot transfer energy from one side to the other. Because there's air trapped in there, conduction can't occur either, because conduction only occurs through solids. Okay, having trapped air prevents that. And if I paint the inside of that wall white, okay, or I put foil on there or something like that, I'm preventing which convection, conduction, radiation, right? I want to reflect it back. Okay, everyone follow me there? Okay, so that's applying your knowledge. So there's going to be a situational question, okay, involving a device or a structure, asking you to apply what you know about those methods of heat transfer, either harnessing them or preventing them, one or the other. Okay, and there's some multiple choice questions about that as well. Okay. Okay, then we talked about wind patterns. Okay, patterns of prevailing winds. Right? Near the equator, we have the trade winds. They're those northeasterly winds. Here, we're at the top of the westerly wind area. And then near the poles, you get the polar easterlies. We're going to get polar easterlies supposedly late next week as the polar vortex descends upon us for a while. Okay, so it's going to get super cold, and the wind's going to come out of the northeast instead of the southwest for a while. Okay, what causes those prevailing winds? Okay, well, that's the interaction between two things. Convection, see again, convection just came up again, okay, and the Coriolis effect, that's the rotation of the Earth. So convection causes air to move north and south as well as vertically, okay, but the Earth rotates underneath it, okay, which makes it appear to come from a different direction because we're moving through it as it's cycling, okay, and that's what causes those prevailing winds. Okay, the jet stream is also a wind pattern, right? So we can come up again there, right? So the diagram that you would have had in your notes is going to look something like this. At the equator, hot air rises, cool air moves in to replace it, okay? That cool air is trying to move from north to south, but because the Earth is rotating this way underneath it, it deflects it and makes it seem like it's coming from the northeast. In our part of the world, where warm air is trying to move northwards, the deflection is this way, okay, giving us our westerly winds. And then again at the pole, you've got air trying to move southward, and as the Earth spins, it gets deflected in the same way it gets deflected at the equator, right? Make sure you go over that. It's lesson 4, global wind patterns. Okay, it's going to be important for you to look at for that. Questions there? Specific heat capacity. You have a 5-mark specific heat capacity problem in the written response part of your exam, and there's a couple of multiple choice questions about what specific heat capacity is and how it could be applied. Okay, like, you know, in a certain situation, would you want a material to have a high heat capacity or a low heat capacity? Okay. Also, application to climate. Water has a high specific heat capacity. That's why being close to the ocean can affect your climate. Okay? The ocean doesn't lose or gain, or doesn't change temperature very much when it loses or gains energy, so it can regulate the temperature of cities that are near the equator. Or sorry, not near the equator, near the ocean. All right, so specific heat capacity will be asked about in those ways. Okay, so you're going to have 1 E equals MC delta T problems in 5 marks. Okay, so that could be something simple like a blacksmith throws a lump of iron in a furnace. Okay, the furnace adds 10,000 joules of energy to the lump of coal that was initially at 5 degrees Celsius and heats up to 200 degrees Celsius. What's the mass of the lump of coal? Okay, so I would have given you the energy, the specific heat because I told you it was iron, okay, and delta T because I told you it started at 5 and ended at 200, right? You'd be asked to solve for M, or, you know, I give you M and ask you what material he threw in the furnace, whatever. Okay, it's going to be one of those kind of questions, all right? Everybody with me on that? Okay, you guys didn't have any problem with those when we did them in class. They were super easy for you. Okay, then we've got the heating curve of water. You have a heating curve of water problem. So remembering here, okay, on your exam, you'll get this formula, you'll get this formula, and you'll get that formula. They're all on the front page of the exam. You don't have to memorize them. Okay? I will also give you any specific heat capacities that you need, and I give you the numbers for LF and LV. You don't have to memorize those either. What you do have to memorize is this shape. Okay? I am not putting the heating curve on there, because I expect that at 15, 16 years old, you know ice melts at 0 and water boils at 100, okay? The other thing you're gonna need to know is what formula do I use for each section of the graph, right? The graph has 5 sections, but you only need to remember 3 things. Anywhere the line goes up, temperature is changing, you use this formula. At 0 degrees Celsius, you're freezing stuff. LF, okay? Use E equals MLF at 0 because that has to do with freezing, okay? You use E equals MLV at 100 because that's when you're vaporizing, V for vaporizing, okay? That's all you have to remember, right? If you can remember what formulas to use on what part of the graph, you're set, because you don't have to manipulate them, and all the other numbers will be given. Okay, so that could be a 6 or 7 mark question on your exam, okay? And all you have to do is plug in the right numbers, okay? So make sure you take advantage of that one. Okay, and then the last thing we talked about, biomes. Okay, we already talked about how in the written response that's going to be tested with the climatogram. In the multiple choice, picture and a description, and you have to identify which biome it is. A little tip for that, don't just look at the picture. Okay, sometimes the picture can be a little bit misleading. would be important to read the description as well. Case in point, a few exams ago, I put the picture that I had for the temperate grasslands for the prairie, that first picture that I showed you, the one that has the cacti growing in it, I put that on the test. And I put in the description, this biome is a productive agricultural biome that has definite seasons, okay? Cold winters, warm summers, and precipitation is variable, but spikes during the early summer, okay? And precipitation can be very high during that time. And then the options I put on there were temperate grassland, desert. I don't remember what the other two were. But a lot of people didn't read the description. They looked at the picture, saw dead grass and a cactus, and they picked desert. Okay? Because they didn't read the description. Okay? So don't just look at the picture. The picture can help, okay? But make sure you also look at or read the description. Because as soon as it says anything about precipitation and spiking, you know it's not desert. All right, so that's how that'll be tested. Okay, questions on any of that? All right, so specifics here. You got 25 multiple choice questions. And 9 written. Okay. The multiple choice questions will cover mostly recall stuff. There's some application. Okay, so there's stuff in there about what part of the earth would be most responsible for energy transfer. Okay, there could be stuff in there about soil horizons or layers. Okay, then you got a few of the biome multiple choice questions. Okay, components of climate versus factors affecting climate. There's 3 questions about the water cycle. Talked about the water cycle, not just about the steps, but also about where energy goes in and where energy goes out of the water cycle. Okay. Then there's some stuff about biomes. There's some stuff about factors affecting climate, energy transfer, parts of the earth and energy, fates of light. Energy transfer, latent heat, energy transfer. Okay. And when I say energy transfer, again, I mean like conduction, convection, radiation, okay, absorption, conversion, okay, that kind of stuff. Energy transfer, albedo, latent heat. Sits in a theme. I think I've said energy transfer like a dozen times already. Okay, and I'm on question 23. Energy transfer. Atmosphere. Energy transfer. 14 of 25 are about energy transfers. What's that?
You really like it.
Well, the whole unit's called Global Systems and Energy, so it's kind of a big topic. Okay, it's kind of important. All right, for your written response, Climatogram, first question. Your map of Canada question. Okay, it's about factors in climate. Global wind patterns and energy transfers. Global wind patterns and the Coriolis effect. Okay. The fate of solar energy, satellite image question. the device/structure energy transfer question. The specific heat capacity problem. The latent heat problem. And then there's a question that asks you to explain the relationship between three things: energy transfers, latent heat, and the water cycle. Okay, questions from you guys? Anything you want me to go over in more detail? Okay, how do you prepare for this test? Okay, the answer to that is, as you're going over your notes and you look at what I'm telling you is on the test, make up your own question about what I've said the questions will be about and see if you can answer it. Okay, so I told you there's a question about a map of Canada. Okay, pull out Google Maps, pick a spot, okay, and see if you can do that. See if you can tell me what you think the climate of that place would be like based on the factors you think would affect it. Okay, that's good practice. You know, look at some climatograms of cities you know, okay, and see if you can figure out, okay, what biome would they be in based on where they are. Okay. Try a few more specific heat capacity problems from the worksheet that I gave you, and a few more latent heat problems from the worksheet that are in the worksheet booklet. Okay, the answers are in there, so you'll know if you got it right or not. And then kind of look at some things around the house that are focused on energy transfer or harnessing energy. So if you got, you know, like I'm not saying like cut open your Yeti cooler at home or something like that. Okay, I'm not saying do that, but you know, you can look it up, see how it's designed, look at structures and devices that are designed to retain energy or capture energy, see how they work. Okay, that can help you to think up ways you might be able to answer those kinds of questions. So you have to look at ways, study ways that you might apply what you know. There isn't that much to know in this unit, but there's lots of ways to apply it, and that's what the test is asking you to do for the most part. Okay, so try and think of ways to apply what you know. Yeah, that's what you need to do over the weekend. Now, I did post this morning a review package, okay, on Google Classroom in the stream, and I'm going to add to it the recording here in just a minute. Okay, this is the start of it. Okay, it's just got some questions on it for you to do as review activities. It's got a climatogram there. What biome do you suppose that one would be from? Without looking at where it is, because I forgot to take the city off. Okay, got a bell curve for temperature, and I got regular, fairly significant precipitation. So it's not near the equator, okay? It's somewhere, okay, north of that. And you've got regular rainfall, but you have seasons, okay? You've got a summer and a winter for sure. Which biome would that fit with? Okay, look at where it is. Almost everything in Ontario would be in this biome. What would it be? All right, well, maybe you guys need to work on that one then, because I'm not going to give you the answer. Maybe you guys need to figure that one out. Okay, maybe you need to look at the picture of where all the biomes are in your notes from biomes. Figure that one out. Okay, but that's what you're going to be asked to do. Okay, I'm going to give you a biome. Okay, you got to look at it, okay, and see, okay, how much does the temperature change? Okay, and don't be fooled, guys, because sometimes the scale on a graph, okay, can really throw you. This has a definite bell curve, especially when I look at the scale, right? It goes from -5 to 20. that's a significant temperature change. But if I had this for something like the savanna, for example, okay, I could have this exact same shape, but it would only go from, this would be like 20 and the top would be 25. Okay, it would look like it's curved, but the scale makes it look that way. It was really actually flat. If I did that same number on this scale, it would look like this, right? It would go like that. So make sure you check the scale, okay, so that things aren't misleading. Like temperature, or sorry, precipitation bars as well. Okay, this could be a tropical rainforest as well until I look at what the actual numbers are for precipitation. Okay, this is 60 millimeters to 80 millimeters, whereas in tropical rainforest, those bars would be at 200 millimeters. Right, so look at the scale. The scale's important. This is the deciduous forest climate. Okay, remember we said if you're going to have a forest, you need regular rainfall. Okay, this has regular rainfall, but it definitely has a winter, gets below freezing. Definitely has a summer, gets warm. Okay, things like that. All right, so I would say you should probably pull that review sheet up and start having a look at that. Okay, doing some of the stuff from there. If questions come up, I will answer them.